Yes, a couple period one. Actually, a couple of period one students were quite disappointed that we were still doing derivatives. Yeah, we'll be doing antiderivatives soon in integration. So, give that another couple weeks. But we need to talk about extreme values of functions. Today we're going to talk about absolute extrema, and then tomorrow, which is Monday, we'll actually talk about relative extrema. I want to keep these two separate. So, we're going to try really hard not to use our calculator. All right? So let's just go through the meanings of these two words. All right? So what are these two phrases referring to? Absolute extrema is another way of saying absolute maxima versus absolute minima. Okay? So an absolute maximum and an absolute minimum. What is an absolute maximum? An absolute maximum is this. A function, here's the definition, f has an absolute maximum at x equals c, and this is, of course, assuming that c is in the domain. Oops, move that down. So where c is in the domain, probably don't need to state that, you would assume that, such that f of c is greater than or equal to f of x for all x in the domain. Okay? So yes, it's a sentence. All it really means is that C is like the highest point on the graph if all the others are below it. That's all it's saying. It's really a very simple idea. So C is the highest point if all the others are below it, obviously. But it seems kind of fancy to write it this way. And then if you want to write a sentence for absolute minima, it'd sound very similar. Something maybe like a function f has an absolute minimum at x equals c in the domain, of course, if, and then f of x is greater than or equal to f of c for all x in the domain. Excuse you. Bless you. All right. Okay, graphically what it means is the highest point and lowest point, obviously. So if you have a graph that looks like this, okay, let's assume that's a function. The absolute max would actually be right here. It is actually the highest point on here. Even if this point over here is exactly the same height, they're both absolute maxes. Okay? So sometimes we have a sort of a contest, like who's the highest point. Sometimes we can have a tie on that. That's okay. They're just both absolute maximum. And then, of course, absolute minima would mean like the lowest point of all in the graph. That'd be this guy down here. Sorry, you're the lowest point. It's okay. All right. You are the absolute minimum. Sounds like an insult. You're the absolute minimum. Okay. So we have the absolute extrema. Okay? So this topic seems really, really simple, right? But it really isn't that simple. Like, the topic is, but the math behind it can get kind of challenging. Okay, and it's because of all the different varieties of graphs and the different special cases and everything. So we'll talk about that more in a minute. The day 2 stuff, we probably don't even need to write this out now, but I just want to remind you just real briefly that if you have a graph like this, let's say, and this point has already stated, we've already stated this guy is the absolute max. And let's go ahead and let's have this thing stop. We don't want to keep going forever. And same thing on the right side. Let's make these endpoints close like that. And this point down here is the absolute minimum. You're the absolute minimum. There are other points that would qualify as maximum. For example, like over here, this point will say, hey, I'm like the highest point in my region. You say, yes, you're the highest point in your region, but there is one greater than you. He's the green point. But the purple point, we could call him a relative extrema, like a relative max. Locally, he's the highest guy around, you know. In his vicinity, he's top dog. He thinks he's all that in a bag of chips. Okay? But we know that the absolute max is that green guy over there, right? He's king of the hill. So, but the purple guy is king of his hill, if you see what I mean. Okay, also the endpoints here, you've got to really watch out for endpoints in calculus. The endpoints, which we often totally don't even think about, this guy is technically the lowest point in his region. He is a relative minimum. If you ask all the points that live in his neighborhood, hey, who's the lowest of all? They say, oh, it's that guy over there at A. He's the lowest one on the whole graph. Okay? Now it's true that the blue point is below it, but in this vicinity, that endpoint is a relative minimum. And so is this one over here. Question?
Yeah, this was on the test yesterday, right?
No, not really.
It was the last question with the free response. It said,
We might need to make that one bonus then. The last question.
yes.
Yeah, it was like
Yeah, you're right. It's the foreshadowing of chapter 4. Hopefully you guys got it right. I think you got that one right, Hugh. Actually, your justification was really good too. So. Yeah, I think I'm gonna have to make that last question bonus. I'm gonna think of it.
so if it had because it had endpoints on it, and you didn't state those,
Right.
it doesn't count. Because it said name all the relative.
I told you not to look at the endpoints. I said from 0 to 10 exclusive, or negative 10 to 10 exclusive. So you were not looking at the endpoints for that
Okay,
one.
cool.
Were some of you worried about those endpoints?
Yeah, I didn't know if it counted or not.
Yeah. Good. Well, you're thinking about it. But listen, this is a graph of f. That was actually a graph of f prime, which is a totally different thing. So, but this is just a graph of f, and we're just looking, hey, who's the highest point? You know, the green guy says, I am. And the purple guy, well, he's king of his hill. So we have all that to think about, but not today. We have to just focus on this, the absolute max and absolute min today. So what I want to do is, I just want to draw my favorite graph, which is this function. Except I can't really draw it. It's supposed to look like a parabola. Let's see here. There we go. The function is f of x equals 4x minus x squared. I love using this problem because I can teach a lot of calculus from this one graph, okay? Okay, so the first thing I can do with this is ask, where is the absolute max? Well, it's obvious. You can see it's right here, right? Here's Mr. Green, right? He's the absolute max. And since this is a parabola, you can use your old rules for vertex, you know? You guys remember this little formula? H equals negative b over 2a. You guys remember this rule? The x coordinate of the vertex is opposite b over 2a. Raise your hand if you remember this rule. Okay, I'm going to show you that this formula is henceforth obsolete. It is totally useless to us. Watch this. This absolute max is differentiable. And there's a horizontal tangent line right there. What does that mean?
Zero.
What's 0?
That's prime is 0.
this is where f prime is 0. Is it not? So why don't we just take the derivative, set it equal to 0, and find that point that way, right? So we did this earlier in year 2. So we'll just find or take f prime. So find the derivative, right? So that's just 4 minus 2x. Set it equal to 0. Set f prime equal to 0. And you get 4 minus 2x equals 0. Solve, and you get x equals 2. And then find f of 2 so that you have the y-coordinate also. So this point is the point 2, 4. So here's how we would write it. Watch very closely. The absolute max of f of x is at 2. The absolute max of f of x is 4. Okay, the wording is really important here. Okay? Our book doesn't go into like all the details on the wording, but when they ask you where it's at, you give the x-coordinate. And when they ask you what it is, you give the y-coordinate. Where is the maximum? Give me the x. What is the maximum? Give me the y. Okay, very important. If you're not sure which one it's asking for, just give both. That's the safest thing to do. Say the max is 2, 4. Okay, that's like the safest thing to do. Most of our book asks you where is the max. Sometimes it says what is the max. The answers to that is 2 and 4 respectively. Okay, where is the absolute minimum? Yeah, this graph has no endpoints, right? Also, there's no lowest point on the graph. So this is kind of an interesting case. But there is no absolute min. That's okay. That just means nobody is the lowest point of all. Okay, now what I want to do is take this same function and I want to start restricting the domain. I don't want to look at the whole thing. I'm just going to ask you to look at little pieces of it. And then we'll talk about like what's the absolute min now and what's the absolute max now and that sort of thing. Okay? Okay, so let's restrict the domain. So same graph. This is the graph of f of x equals 4x minus x squared. But let's say that we want to look at, let's let g of x be f of x, but restricted. So only from 0, or I should put on the domain 0 to 3. So what this means is you're just going to be looking at this part only. Zero to 3, see? That's all you want to look at. And I know that because it's just giving me those as endpoints. So try to understand that notation. We already know the vertex is at 2, 4. What is the absolute max? Yes, the absolute max is still 4, and it's still at 2. So we'll still put that it's at 2, 4, and it is 4. It's at 2, and it is 4. Okay? But now there is an absolute min, isn't there? What is the absolute min? Yeah, there is a lowest point now because I've defined to be just discussing the purple section only. So we can now say the absolute min is 0, 0. It is at 0 and the minimum value is 0. Okay? That's what happens when you restrict the domain. Okay, so that's the purple problem. All right, let's do it again. This time we're going to switch the domain and we'll do h of x. Let h of x be f of x, but only on the interval 0 to, let's do 5. So this means between x is 0 and x is 5, as you know. Right, you know that. Okay, so let's just move our graph down the page. Grab all that. Okay, you come on down here. Okay, we're going to keep talking about you. All right, got a little corrupted there. That's okay. So let's look at that now. We're now looking at this domain. So we're going from 0, it's open now, to 5. How do I know that 5 is under the x-axis? Well, the function was f of x equals 4x minus x squared, which has the roots, 0 and 4. So these are actually 0 and 4 are the roots. So 5 must be under the x-axis there. So looking at the red, we would like to go ahead and see where the absolute max is. Well, the absolute max is where? Still the vertex. What's that? Oh, yes. Sorry about that. This is an open circle. Thank you very much. A+ for today. Okay. So where's my absolute max? Absolute max is still 2, 4, right? That hasn't changed. Where's my absolute min?
4.5.
So this is kind of an interesting question. Who's the lowest point of all? There is none. Okay? There is no lowest point. If you look closely at this part, this is sort of the spot you're probably looking at right now, right? You're probably looking there because that's like the lowest place on the graph. That's what this looks like. This is what this looks like up close, right? If you zoom in, looks like that. But if you say that this is the lowest point, let's say at 4.99, right? There's still a point to the right of it at 4.991 that's slightly below that. In fact, you could actually get as close as you want to 5, and there's always another point slightly below the other one that you just looked at, see? So there is no true minimum here. It's kind of a weird idea.
So it does not exist.
It doesn't exist. There's none. So you can see why I had to put this on here. This is just a special case. If what appears to be the lowest point on a graph is an open circle, then we actually don't have a lowest point. You can think of it that way. Same thing is true for a maximum. If the highest point on your graph is open, then there's no absolute max. Okay? All right, how about this one? Let's do same graph. Let's go green. So, let's go green, same graph. This time, m of x is f of x, but it's on the interval from 3 to infinity. Right? Now remember, this is the point 2, 4, and that point is no longer in the domain. Our function is a new function. It starts right here. And then it goes on forever. Okay, so what is my absolute max? Well, we might need to find the coordinates of this point, right? If f of x is 4x minus x squared, and we are at 3, then this is going to give me 4 times 3 minus 3 squared. In other words, it's 3. So this is the point 3, 3, right? And it is the highest point around on the green graph. So there you go. What about an absolute minimum?
Doesn't exist.
None. Right. Again, we see this has no absolute minimum. This time it's for a different reason. This graph literally keeps on dropping, so we don't have an absolute minimum. Okay, so you guys see how restricting the domain kind of changes our view of things? Okay, it's a pretty simple idea, right? So, okay, yes.
Is writing does not exist or D&E for like these make sense, or are we not supposed to do that?
D&E is used when a derivative doesn't exist or a limit doesn't exist, because a derivative is actually a limit.
Right, so don't use D&E for those.
Don't use D&E. We don't say the point doesn't exist. We say the point is undefined sometimes, or there is no point. But we use the word D&E for limit type stuff. So like derivatives and limits specifically in calculus. Okay, you guys, so much for the idea, listen, so much for the idea that you can just take the derivative and set it equal to 0 to always find the maximum. That is not even a true statement. That worked out great on the first example at the top. That's exactly how we found the maximum. But once the domain is restricted, the derivative might not even be that important. Like, look at this. Why would you set this derivative equal to 0 on this green graph? There are no horizontal tangents anywhere on this green graph. If you set this derivative equal to 0, you'll find that x equals 2. Okay, take the derivative set equal to 0, you get x equals 2. That's this point. It's not even on the graph. You see my point? So it's really important to understand that absolute maximum and absolute minimum is more than just talking about the derivative is 0. Because a lot of students come in with a little bit of calculus knowledge, and it's a dangerous thing. So you say, how do you find the highest point on a function? Take the derivative set equal to 0. No, not really. This highest point is not a horizontal tangent. It's an endpoint. Who knew? Okay, so if it is not safe to say this statement is not quite true, right? The absolute max is where f prime of x equals 0. This is not the whole truth. This might as well be a lie. Okay? Okay, so then can we do this? The absolute max is either an endpoint or where f prime of x equals 0.
No, because we have multiple.
Is this true? It's not quite true either. Look at this graph, for example. Watch. On this graph, where is the highest point? At the third peak. Is the derivative 0 there? No. Is that an endpoint? No. So if you came in this year thinking that I will find the highest point on a function using the derivative, setting it equal to 0, that's not the whole truth. If you came in this year thinking the endpoint is usually like the highest point or lowest point, that's not quite true either. If you really want the true statement, you need to think 3 things. Okay? There are 3 possible locations for the absolute max or absolute min. Here they are. Ready? This is a very important statement. I'll write it in a different color because it's so important. Somebody pick a color.
Purple.
Purple? Do I have purple? Yes. Okay. The absolute extrema, that means absolute max or min, occur at, and there are 3 possibilities, an endpoint, a point where the derivative is 0, or there's a third case where f prime does not exist. A sample graph will show that. In this first picture, the absolute min is here. It's an endpoint. The absolute max is here. It's the other endpoint. The second diagram will show you that it can happen where the derivative is 0, like in this picture. This might be like a sine wave. The absolute max occurs where f prime is 0, and so does the absolute min. The third diagram will demonstrate the third case. The absolute max is this point right here, but it's not because it's an endpoint, and it certainly isn't a horizontal tangent. There's a sharp turn there. The graph just turned sharply and went down. That's why that's the highest point. F prime does not exist. And this point is the absolute min for the same reason. F prime does not exist. So there are really three facts that you need to know. You need to know that absolute extrema occur either at an endpoint or where the derivative is 0 or where the derivative doesn't exist. Okay, so this statement is super important. In fact, this whole chapter is full of important sentences. Okay, I'm going to give you a whole page full of sentences in a couple of days. So make sure you have this thing written in your notes, highlighted. And let's try some examples. So far I haven't done much with functions, right? So let's try this problem here. Find the absolute extrema. You're not allowed to use a graphing calculator. Do not graph them on the screen. That takes all the fun out of the problems. Okay? Without, and same thing with homework tonight, without a graphing utility, without a graphing utility, find the absolute extrema. Okay, the function for number 1 is simple. Y equals e to the x. And the domain, -2 to 2. -2 to 2. Now, if you know what the graph looks like, this problem is so dang easy, it's ridiculous, we might as well not even do it. But I would rather use the sentence and try to understand how that sentence applies to this problem. So let's go back and look at that sentence one more time. It says, the absolute extrema occur when you're at an endpoint, or where the derivative is 0, or where the derivative is not defined. So I'm not actually going to find the derivative yet. I'm going to check the endpoints. Okay? Here are my endpoints right here. Maybe these are the absolute min and max. Maybe that's all there is to it, right? But we're going to go ahead and test endpoints first. So for endpoints, we're going to find f of -2, which of course is just e to the -2, and f of 2, which of course is just e squared. Now, what are these numbers? I told you not to use a calculator. So who's bigger though? E squared or 1 over e squared? Yeah, as long as e is a number greater than 1, this is the bigger number. You guys agree? And e is like 2.7. So this is really close to 9, and this is really close to like 1/9. Okay? So obviously, right now, he is the only candidate for absolute max, and he is the only candidate for absolute min. So maybe that's the answer. But we still have to look at the derivative. Okay, so now let's look at the derivative. So now we look at, these are called critical points. Critical points means x values where f prime equals 0 or f prime doesn't exist. Probably should have defined that word earlier for you. Okay, let's go ahead and find the derivative. So f of x is e to the x. What is my derivative? Okay, that's not very interesting. But if I'm going to be studying horizontal tangency, right? Because those guys are candidates. Let's set it equal to 0. So set f prime equal to 0. Let's try to solve that. Okay, so you need to know two things about the exponential. Okay, one is the domain is all real numbers, and the range is always positive. So whenever you see an e to the x or 5 to the x or whatever, it's shouting, "I'm positive." Okay, you should hear it shouting. Can you guys hear him shouting, "I'm positive"? E to the x is shouting, "I'm positive." Can you hear him? Do you hear him? He's shouting it. He's shouting it. I can hear him very clearly. Of course, that's me. I'm hearing voices. E to the x is talking to me. He's saying, "I'm positive, I'm positive, I'm positive." So this is not going to give me any more candidates. This statement is never true. So this was a bit of a dead end, granted. But I still needed to at least think it. So that's a no solution. We also need to, and I say this tongue-in-cheek, set f prime equal to undefined. Okay? So e to the x is undefined. Would this ever happen? Are there any numbers that we cannot plug into e to the x?
All real numbers.
Yeah. So listen, e to the x shouts two things. E to the x shouts, "I'm positive," and it shouts, "I'm hungry." Can you hear it? I can't. It means e to the x will take any number. You can put any number into e to the x. You'll never get undefined. You can plug in 1,000,000, -1,000,000, pi, 0, even e. All exponentials have an all real numbers domain. That means you can plug anything you want in. This should never happen. Okay? And this should never happen. So we just have no more candidates. Both of these are dead ends. That means our original candidates, these guys up top, are the actual answers. This is our absolute max. The absolute max is 2 comma e squared. The absolute min is -2 comma 1 over e squared. These are them. They were all the while. Now, if you know what the graph looks like on this problem, that sort of takes the sting out of it, because the graph just looks like this. It's all very trivial. E to the x just goes like this. And yes, the endpoints are the lowest and highest points. Right? Look at it. And there are no horizontal tangents anywhere in there. That's our conclusion here. Right? There's no horizontal tangents. And this means there were no corners, no cusps, no vertical tangents, and no breaks. As you can hear here. Yeah, we knew that. So this was the answer all along. It's really, really simple. But we had to test endpoints and points where the derivative is 0. There weren't any. And where a derivative doesn't exist, although there weren't any. Yes?
So what you do if you do get like f prime equals 0 and f prime is undefined, you have to find those x's and plug them back in, and then whichever y is larger.
That's exactly right. Okay, so let's go on and talk about a more interesting function. How about this problem? F of x equals cosine of x plus pi over 4. Same instructions, find the absolute extrema. This time the domain is 0 to 7 pi over 4. Okay? 0 to 7 pi over 4. Now, if you know what the graph looks like, that spoils everything. So let's not try to think about the graph too much. Let's just try to apply what we learned. We said that the candidates for the king of the hill, right, the highest point of all, is either it's an endpoint, or it's where the derivative is 0, or it is where the derivative is not defined. So let's run through the 3 possible cases. Let's check endpoints first. You know why I check endpoints first? It's because I often forget to do it. So I do them first. Let's find f of 0. Let's find f of 7 pi over 4. What is cosine of 0 plus pi over 4? That's right, root 2 over 2. What is cosine of 7 pi over 4 plus pi over 4? 1. Who's bigger? Without a calculator, who's bigger? 1. Rad 2 is about 1.4. Dividing by 2, this is about 0.7. Obviously, that's less than 1. So our only two candidates right now are we think that 1 is a candidate for absolute max. He might be king of the hill. We'll find out later. And this guy, he's the only candidate we have for absolute minimum. But there's more to check. So now we're going to take the derivative of cos of x plus pi over 4. This is called finding critical points. And it's a two-phase thing. It's set f prime equal to 0 and set f prime equal to undefined. Okay? It's a two-stage argument. Well, what's the derivative? F prime is negative sine of x plus pi over 4, right? Don't change my angle. Right? Okay. If I set that equal to 0, you can kind of do this in your head, because you guys are actually pretty good at this stuff. You know your unit circle really well. So you just ask yourself, what kinds of angles have a sine of 0? Well, pi does, right? And so if this was like a 3 pi over 4, and you add a pi over 4, you're going to get pi. So 3 pi over 4 would make this statement true. You can just tell by looking at it. Also, 2 pi, right? Sine of 2 pi is also 0. So if that was a 7 pi over 4. So instead of like solving this whole thing, just look at it. X equals 3 pi over 4 would make this true. X equals 7 pi over 4 makes this true. Negative pi over 4 would make this true, but it's not in our domain. See? So just pick out whatever numbers you can think of that make this true from the domain. Okay, so I'm coming up with 3 pi over 4, we said, and 7 pi over 4. Now, are either of these new? Yeah, we already actually looked at 7 pi over 4, but we have a brand new candidate. See him? Let's find f of that. F of 3 pi over 4 is cosine of 3 pi over 4 plus pi over 4. Ooh, negative 1. We just got ourselves a brand new candidate for absolute min. I'm going to go apologize to f of 0 here. F of 0, we thought you might be the absolute min, but we found a new guy down here, and we think he's going to be the absolute min. I'm sorry, you're not the lowest point of the graph. I don't really want to be the lowest point of the graph. Okay, great, you're not. So, you're not the absolute min. You probably are. Have fun. Okay. We're having a blast. So we apologize to point 7. He does not qualify to be scumbucket. Okay. Let's look at f prime being undefined. Negative sine of x plus pi over 4 equals undefined? Huh. Have you ever typed sine of something and your calculator said error? Never. Unless there's like a rad x here and you try to use negative 1. But if you have a sine function, it has an all real numbers domain. So sines also say, I'm hungry, give me anything. Okay? So this is a dead end. But we still had to do this. We still have to at least think this. We have all the candidates. There's 3 of them. Okay? Be careful how you answer the question. Here's the final answer to this problem. We have an absolute max at, and the biggest y-coordinate we found was this guy. He's the biggest y that we ever got. So it is the point 7 pi over 4, 1. That is the absolute max. Absolute max is 7 pi over 4, 1. And the absolute lowest point was actually our third candidate, 3 pi over 4, negative 1. As for that other point, remember when we tested 7 pi over 4? I'm sorry, when we tested 0? I guess it's just neither. It's not that important. Maybe he's a relative min or something. But that's for Monday. That's Monday's lesson. Now, if you can see the graph for this, the whole problem is the stupidest problem in the world. Watch. It's so easy. We're talking about y equals cosine of x plus pi over 4, which is a simple cosine graph shifted to the left by basically an eighth of a period. It looks like this, guys. This is 1. It comes down like this, hits the axis right here, comes back up. Like that. 2 pi is actually right here. The interval we were looking at was right here. Zero to 7 pi over 4, just shy of 8 pi over 4. Where are the absolute maxima? Did I do this right? Hold on. This point is a little bit higher than the other one. Where's the absolute maximum? 7 pi over 4, 1. See what I mean? This is not. My mistake is in the graphing here. When I shifted, I didn't shift this right point over. There we go. This is the highest point. It's back full cycle to the top. Okay, so there we go. He is the highest point. He is the lowest point. It's so easy when you have the graph, right? But the calculus feels tricky when you're not looking at the graph. But you can easily confirm it, right? So just try to stay away from the calculator tonight and try to get the math done. So now I'm going to let you try a problem, okay, all on your own for the rest of the period. And it is this problem. Find the absolute extrema of f of x equals, and it is x minus 1 to the 2/3 plus 1, and this is on the interval -3, I meant to do -1 to +3. This will take you the rest of the period, easy, okay? Because you have to go through all 3 considerations. What are my endpoint values? What is my derivative? When is it 0? When does it equal undefined? Get all your candidates, check all their y values, and see who's top dog and who's the lowest. You're not allowed to use a calculator, so you're going to at some point have to decide if you think the number, 4 to the 2/3 plus 1 is, bigger than, 2 to the 2/3 plus 1. You're going to have to estimate, okay? That happens. Don't let that discourage you.